Ionization energy. Ionization energy talking about remove electron. Electronegativities. Electronegativities talking about attraction of electron. Now I'm going to focus on the ionization energy. And let's begin. What is ionization energy? Now let's redefine. Ionization energy is a measurement to see how much energy you need to remove electron from an atom. Let's repeat. Ionization energy is a measurement to see how much energy you need to remove electron from an atom. And now let's explain what's that mean. I give you an example. Now let's look onto 3 atoms of ionization energy. But before we talk, we have to mention about energy, because you need energy to remove electron. Student, please understand one concept. In our surrounding, there is already have a lot of energy. If you're talking about no energy, where you will have no energy, you have to go to the outer space, which will go minus 300 degrees at absolute zero. Then that will be the place of no energy. So if you're at home, even at a very cold day, 0 degree, there is a lot of energy already around you. They say how much energy you need so that this electron will be giving out. You say you just need tiny bit of vibration, very little energy, 375.7 kilojoules per mole. So you just need so little energy and the electron will be giving out. So you can say in this situation, this type of atom at room temperature, if you are at room temperature, definitely they will give out the electron. They will just give out the electron. Too much energy for them already. So they will give out electron. They strongly tend to lose. On the next group, these take more energy, around 700-ish. 700 kilojoules. That means you need a few hundred degrees of a temperature. If you give that much energy to nudge onto this atom, this electron will giving out, and they will give out the electron. When you go to the top corner group, the top right corner group, you see that the temperature are even much higher. It go up to 1600 degrees, almost to 2000 degrees, 2000 kilojoules. That means you want this atom to lose the electron. Yes, they can do it, but not easy. If you can put a few thousand degrees onto this atom, they will give the electron out. Repeat, if you put a few thousand kilojoules of energy, they will give out the electron. So in other words, they don't quite easily give out electron. They only weakly want to lose the electron. So the strongly losing electron, the one strongly lose electron, which in the other words means they are highly reactive at room temperature. They are highly reactive. On the weakly loose electron at room temperature, they are less reactive, or they are quite unreactive. So on the periodic table, you can see the trend. the highly reactive one, which is the ones require very little energy, and they can lose the electron, which is at the corner. And the trend go up towards the other corner. The other corner which require very high energy. So you can see that is the less reactive. A chart of ionization energy. Here, that is a chart which this chart corresponds to the periodic table to demonstrate once again of this trend. On this chart, look onto the x-axis, atomic number, y-axis, energy level, from low energy to high energy. And now let's see how this chart corresponds to periodic table. On the period 1, that's what show on the chart. Period 2, that's what show on the chart. Period 3, that's what show on the chart. Out of this period, which going to be the most reactive? The most reactive means they needs less energy to lose electron. That means they're going to be low in ionization energy. So watch. Those low in ionization energy going to be the most reactive. As look on the periodic table, going to be on the first group. And now what is the least reactive, unreactive? And this one will be less tend to lose electron. And they require high energy in order to lose the electron. Which group going to be? The top group. You require a lot of energy. The group number 8, those inert non-metal, those inert gas. They don't want to give electron until you put very high energy for them to lose electron. They are less reactive. So again, the same trend is just to show the metal have strong tend to lose electron than the non-metal.